Hi guys, what I'd like to do for you today is a demo that we would normally do in class. The demo is called Evidence for Chemical Change. So what we're learning about in this unit are different types of chemical reactions, and what we're going to be doing in this activity is observing different types of chemical reactions. More specifically though, we are going to be looking for evidence of change as each of these types of reactions take place. One way of knowing that a chemical change has occurred is to observe that the properties of the products are different from those of the reactants. We'll make observations before and we'll make observations after each reaction takes place. At the end of each reaction, we have a new product, and that new product can then become a reactant in another reaction. In this experiment, we will observe a sequence of changes that occur when a solution that begins as copper 2 nitrate is subject to a series of different reactions. All of the reactions will take place in this same small test tube. At each step, we will look for evidence that a new substance has formed as a result of the reaction that occurred. We will also make observations about energy changes and relate them to chemical changes. So in front of me I have almost everything that I need. I'm missing a piece of aluminum foil, but at some point I will run and grab some so that we can finish making our observations. To begin, I have my safety goggles on, I've set up my boiling water bath, I have a cool water bath, and I have my test tube, which has very specific markings on it. To begin, I am asked to take my blue copper 2 nitrate solution and add it to the test tube up to the first line. There we go. What I can observe here is that this solution is blue and that it is transparent. The first change that I will observe is a change that happens when I mix a second substance with it, sodium hydroxide. And I don't think I have enough, which is why I brought my bottle. So I'm going to place down my test tube. And I'm going to get some more. Test tube again, and I'm going to add sodium hydroxide up to the first line. And it may be difficult for you to see, but what I can see already happening is the formation of a blue solid where the two solutions mix. I'll continue to mix these two solutions. And now you can truly see that this blue solid has formed. I feel the test tube to check for warmth, and it is warm to the touch. What that means is that my products are at a lower state of energy than my original reactants. My reactants, which were sodium hydroxide and copper 2 nitrate. Because they're at a lower state of energy, energy was given off, and the reaction is said to be exothermic. In the second part, I'm going to observe energy, no, maybe not energy, but I'm certainly going to be using energy to force a second chemical change to occur. And that second chemical change is going to be via a decomposition reaction. The blue solid is going to change into something else. I'll take my test tube tongs and I will add this to my boiling water bath. What I can see here is that my blue solid has now changed color and it is clearly turned black. In this decomposition reaction, the evidence for change is the color change. blue to black. Before I can go on to my next step, I have to pull this down. So I'm going to let this sit in my second beaker of cool water while I unplug my heating element and move the boiling water over. There we go. I'll be back in 2 minutes after our test tube has time to cool for our next change. Our test tube has been allowed to cool, and now we are going to make another observation. In our next observation, what we're going to be doing is causing a reaction between the black solid and hydrochloric acid. I'm going to add hydrochloric acid up to the final line. Okay. And what I can already see is that the acid is starting to, quote, dissolve the black solid. So let's do some mixing. We'll continue to mix. You can see the solid is breaking apart. And all of a sudden, the solution is changing color. Black is disappearing, and even the blue is disappearing. And what we have now is a largely greenish solution that is transparent. Okay. For our last reaction, what we're going to be doing is actually observing two things. One, when I add this aluminum foil, the aluminum foil is going to react with the copper ions that are in this solution, and it's the copper ions that give it its color. Another thing that's going to react is the hydrochloric acid that I added. There was too much of it. So there's going to be what we call an excess, or some hydrochloric acid left over that didn't react with the black solid. When it reacts with this metal, we'll observe bubbles. All right. Now this reaction takes a little bit of time. I'm going to do my best to attempt to bring this close to the camera. And I hope that what you can see is that bubbles are already forming on this piece of aluminum foil. And again, those bubbles are a sign of the one reaction, the reaction between aluminum and hydrochloric acid. But remember, there is a second reaction. And the second reaction is the reaction of aluminum with copper ions. That reaction we can see through a color change. And if you carefully look at the aluminum foil, especially on its sides, you can start to see that there's a brownish color forming. What that brownish color is actually elemental copper. So the aluminum ions are switching places with the copper ions. The aluminum, which was an element, that's why it's the foil, is now going into solution, and the copper ions, which were in solution, is now coming out as copper metal. If I mix it, we might even be able to see some of this copper fall to the bottom. All right, so this brown flakes, that's elemental copper. Now eventually, what would happen is that this blue color would disappear because all of the copper would be at the bottom of the test tube as that brown metal. And all of the aluminum would be in solution. And aluminum ions, when they're in solution, are colorless. Notice that I felt the side of the test tube. I'll feel it again, and it feels warm. Again, these changes are exothermic because the products are at a lower state of energy than the original reactants. That excess energy is given off in the form of heat.